Hey everyone, this is Duke here with a video related to the hardware identification, some soldering tips, and our wiring diagram for our class this semester. So in our TL Draw, which I really enjoy using the TL Draw, I just think it's a great digital whiteboard type tool here. I have created a section called Autonomous Plane as opposed to our non-autonomous plane or basic RC plane we did earlier in the semester. I tried to find some nice images of the components we would need for you guys. Of course, you can find your own images and just copy paste them in here. That works great too. But essentially here we have, I think we should have everything we need to do in the wiring diagram. So we have our stuff from before, our transmitter, our battery, motor. We have 4 servos this time instead of just 2. And we have a choice of receivers, whether it's a serial receiver or a PWM receiver. Then we have some new components as well. Maybe I'll stack these up here a little bit more. Some new components as well, and that is our flight control board and USB extension board and our GPS. Okay, so those are all the new autonomous added items, I guess you could say. And with the SpeedyBee board, I added 2 pictures here of the main flight control board, the front and back of the board. We have the PDB board here, just one side of it showing because the other side doesn't have anything on it. And then we have our USB extension board here. So just a few things to note, and you'll see a lot of this in the instruction fold out that you get with your flight controller. So again, don't throw that away, it's really useful. But here in the pinouts, we can see different things where wires are supposed to go. So one of the things we're going to look at first is where we connect different items. Let's take a look here at our USB extension board. So we have this plug that's going to be plugged into our flight controller. Here's our USB over here. And so we want to make sure we have this plug in correctly to our flight controller. So I'm going to actually switch where these position are position-wise, okay? And rotate this around because now you might want to rotate the other way, up to you, but just to show you for demonstration here, we have our, oh, I rotated the wrong way. My bad. It does need to go this way. Sorry, look at the wrong port there. Okay, but here is our USB port here, and here it is on the USB extension board. So naturally, we want to make sure we plug the USB extension board into the flight controller correctly. Now, they already have a harness for you to do that. That's going to match up and stuff. That's fine. But if you take a look at that harness, you'll realize that these pins match as they go across. So it's kind of inverted, I guess you'd say. The 4v5 here, let's just draw a couple of these. 4v5 here is going to be plugging in down over here. Ground is going to go over here. I can't draw very well with the mouse. You get the idea. If you look at that harness that's included with the flight controller, it's going to be connected in that fashion. So I want you guys to understand that and know where everything's going on that. And then we can scoot over here to the other side of the flight control board. I guess the back side technically. And here we don't have much going on that we need to worry about too much, I guess, per se, except for we need this GPS compass port here to connect to our GPS correctly. So we're going to move the GPS over here, going to move this over here. And so in this case, we might turn this one a little bit perhaps, okay, and this one maybe a little bit to help us better visualize where things are going to go here. So we have SDA, and it's going to go at SDA. So in this case, you want to remember the SDA, and we can just draw it up here to the letter. I wish I had a stylus or something. In this case, you want to realize and remember that on GPS compass combos, we typically have a GPS and then we have a compass, right? It makes sense. Sorry, I'm trying to draw and talk at the same time. It's not working out so well. And our GPS is a serial device. And so our GPS, TX, and RX need to be swapped to go to the flight controller TX and RX. So what that means is the TX here, I'm just going to draw this in, let's see, purple. Okay, the TX here is going to need to go to the RX here, and then RX here is going to go to TX here. So they kind of get switched depending on which way you're looking at it. It doesn't really matter either way, they got to go to the opposite thing on the other board. And now that wiring looks horrible. It would be better to draw it with lines and have nice crisp curves and stuff for this. But you get the idea. We're trying to show which ports or which wires go where on the different components. And again, the TX and RX are going to swap. So TX to RX and RX to TX. But the SCL and SDA do not swap. So SDA here goes to SDA here, and SCL goes to SDL. or SCL, sorry. So whenever you have a UART device, which we'll also see on a receiver or a serial device, you want to swap the TX and RX. But if you have a I2C, that's what this is called, SCL and SDA I2C device, you just go straight across. Okay? So there's our GPS to our flight control board. And then if we go over here and grab our receiver, I'm going to use the serial receiver in this example. I should have grabbed a photo of it the other direction. Let's find a photo with it. Here it is. Let's grab this one so we can see the pads, which will be much more helpful. Okay, sorry about that. So we're going to take our receiver, and receiver should have some kind of labeling, whether it's on the actual receiver or on the backside or on the documentation or whatever it is. Should have some documentation somewhere about which ports are which. And over here on our receiver, we're going to be wiring this to the flight control board. I'm going to use the top side of the board for this demo since it's not colored. This one's got these nice colors for the manual, but for what we're doing, let's not use that one. So we're going to go here, kind of turn it at 90. And since this is a CRSF cable receiver, we're going to be wiring it to the T1R1 set of pins up here. So what that means again is we have our, let's see, let's go negative. So negative is going to go over here to our, try to make it a little bit straighter, ground. Okay. Power is going to go to our, between here, 4V5. And then we have TX is next. That's going to go to RX on this R1 pad. So R1 is RX for UART1. And then we're going to go ahead and grab this blue here and move this RX pad from the receiver onto the T pad of our flight controller. Yeah, it's a little bit neater. And so with our receiver's UART, which is Universal Asynchronous Receive and Transmit, that's what that UART stands for. It's a serial communication between our receiver and our flight controller. We want to basically take the TX, so the transmit from the receiver needs to go to the receive on the flight controller, and the receive on the receiver comes from the transmit on the flight controller. So kind of one-way street here. The TX is talking, the flight controller is receiving, the flight controller is talking, the receiver is receiving. Okay, and then we have power and ground, which is power in the receiver. So we have our GPS with the TX and ARC swapped there, and we have our receiver with the TX ARC swapped as well. So those are a couple examples of UART or serial devices connected to our flight controller. And then the only other thing I wanted to point out in this, I guess, hardware page or the whiteboard we're using TL Draw is on our PDB board. This is the top side of the board, and it is pretty much the same as the bottom side in terms of layout and stuff like that. We have a few extra things on the top side of the board that you may be interested in, though not specifically needed for our plane this semester. Okay, so over here we have the positive, 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 negative, negative, negative. This is designed for the power to come into the board on the positive and negative bigger pads, and then your ESC to connect to the board on the smaller pads. Okay, you want to have the XT60 come into the board here on the ends, and then the ESC power to the ESC go off here from the middle. So if we kind of draw that out, let's zoom out a little bit more here. Grab our, oops, I forgot I'm still on the pen tool. Grab our pigtail here and our ESC here. And we're going to go outside the box a little bit just because I don't want to make a new box right this second. But essentially what we're doing is we're going to say, okay, our power leads are going to come into the board here. And we're going to use white for negative since I have the TL draw in dark mode right now, like so. And then for the power to come to the ESC, we're going to come out of one of these middle pads. It doesn't really matter which one. Okay, so we're going to go over here to the positive and over here to the negative. A little bit hard to see on the white background there, I apologize. But we're going to the negative with this wire here. Okay, and that allows the flight controller to not only get power, but also to measure things like the current flow or the voltage of the battery, because the power flows through the flight controller and then back out to the ESC. So basically all the power in the system is coming from the battery. It's all going through the flight controller. That allows the flight controller to measure the power and give us good information like battery voltage and things like that when we're flying. And so that's really helpful. The only thing you might be concerned about is if you're trying to use a video transmitter with this semester, which is not part of the class, but I know at least one student was interested in that. Just be aware of this little set of pads here. If you look at the manual, I'd highly recommend looking at the manual for this. You need to select what voltage you want for your video transmitter, whether it's 5 volts or battery voltage here. Okay, that would be something you want to pay attention to. The other solder bridge pads over here, we won't be using this semester for 6-volt servos, which we don't have. And then this one, I'm trying to what that does, but anyways, this one might be of interest to you if you're running a video transmitter this semester. You want to add it to your plane later on or something like that. Okay. So then we have remaining in our autonomous plane setup, we have our motor, which I think you all probably know where that goes by now. Over here with our ESC, kind of line those up. There we go. And then we have our servos. Okay. And if we're going to plug our servos in, we need to know where those go into, and our battery can go over here, I suppose. Plug into our pigtail lead there. Our servos are going to go in this area. So this on the front of the board, or the top of the board, we can see it here. In the back, it's the same kind of thing. It's just kind of flipped because the board's flipped over in the photo. One thing I want to point out is we do not plug anything into the S-bus set of pads or pins right here unless you have an S-bus receiver, which I don't think anyone's using this semester. So we skip those 3 pins right there, and then we have S1, S2, S3, and S4. Okay, and those are going to be our main control surface ports for our servos. So if you remember the channel order, aileron, elevator, throttle, rudder, AETR. So these will be where our servos we plug it into. So I'll let you guys draw that over from our servo. We want to find a different picture of a servo to port 1, that's our aileron. Port 2, elevator. 3 is our ESC, actually not a servo. Sorry, we don't have 4 servos. We just have, well, we have 4 servos, but we're just using 3 sets of pins. For one set's for our ailerons. Let's go here. So we have 2 servos for our ailerons. We're going to be putting those into a Y harness for 1 set of pins here. So we have ailerons, elevator. Okay. So we'll kind of mash these 2 together. And there's our ailerons, elevator, and then we have our throttle. So you might want to rearrange things a little bit, but your ESC lead here needs to go all the way over to channel 3. And then our last servo is our rudder. Okay. So there's our rudder servo into channel 4. Okay. So that'll become the default configuration you'll use, and that would be how you'd wire things up. I hope that helps explain a bit more of what's going on here with the hardware itself, the different boards and things like that, as well as your wiring diagram layout. I apologize for the hiccup on the ailerons there. We are using 2 servos, one for each aileron, but they're going to be going into what's called a Y harness, so you can just draw them both into the same set of pins here on S1 because they'll both be plugging into that essentially on the airplane. Okay. If you wanted to plug them in separately, you could do that as well and do other things with the ailerons that might be more advanced, but we're not going to really cover that in class as in terms of the whole class doing it that way. All right, so with RTL draw, kind of sorted out there a little bit, we're going to swap over to the dock cam or the overhead camera for a minute. Oops, zoomed way in. Okay. And I want to give you a few tips or tricks with the soldering and setup, just physical things here to pay attention to. Okay, so when you're soldering on your flight controller, whatever layout you decide to choose, whether it's this one or some combination of the 2, okay. Your bottom board here is the PDB, the power distribution board, has pads on both sides. So you see I soldered it to the top of the board here. You can kind of see the soldering there. But of course it has pads on the bottom, so depending on which way you mount it, you use one side or the other. And that's okay. Just make sure you get a nice, tin on these pads. We want them to be nice and have a nice pillow on them before you attach the wires, especially on the negative side. It will require some extra heat to heat up those pads enough to get the solder flowing as it should. Okay. So you want to make sure you attach the leads there correctly, as well as attaching your capacitor. Remember you have, let's turn it this way, The two ends here where my thumbs are at are for the battery input. So that's where our battery lead would plug into. That would be an XT60 male pin, female plastic. The middle sets of pads here are for ESCs. So again, I have two plugs here because I use this on a different plane. It was a twin, so I had two ESCs. You'd only need one, but you need to have one XT60 of the correct length and everything with the female pins, male plastic. Okay, and then your capacitor will really go anywhere you can kind of fit it on here. I think ideally it would be better to put it on the battery input pads, but it's kind of, I don't know, I guess I could have stretched it out that way. I put it on the ESC pads in the center here. So if you had used the outermost two for your battery and the next two for your ESC, you could put the capacitor in the center two. I think that'd be okay. We're only using 3S batteries this semester anyways, so capacitors aren't quite as essential, but you might as well attach it since you have it. Okay, so that's our PDB kind of soldering considerations there, and that'll get mounted and oriented in the way you choose on your flight controller. And then the other note here is on these pins. Okay, so you can see I use the straight pins. You can use the straight pins or the 90-degree pins. Either way is fine. But on the back side of the pins, that's about as far as we can zoom in, you want to make sure you get the pins inserted and then solder only one pin and make sure that it's nice and straight and level and everything before you go soldering the whole row. I've screwed stuff up like that before where I go, oh, yeah, I think it's pretty good. I'm just gonna do a couple of them and then check. But the problem is if you do a couple, then you can't easily unsolder them and make adjustments so that it's not tilted or crooked or floating. The pins are floating or something like that. Okay, this is it looks like a little bit tilted to me actually, honestly right now. But try and get them as straight as possible and check that after the very first pin of the row because these are all connected with the plastic piece there. Okay. Even more important on the 90-degree set because they're all connected. So put one in, just double check, make sure it's seated properly all the way down and everything is looking good there, and then go ahead and do the rest of the row. If you're doing separate rows like me, then again, check on the first one of the row, then do the rest of the row. First one, check. If you do a 9-degree set, you can kind of do one, check it, maybe do the other side to kind of pin it down, or no pun intended there, to tie it down, and then do the rest of them. And then this set of 4 up here, so this white set of 4 white pins right there is kind of tucked up there a little bit. Same thing there, do one and then check it and make sure it's aligned because all of these have to kind of sit next to each other. So if you do the 3 separate rows of pins or the 90-degree set, you still want it to be nice and flush so you can get that set of 4 in there for your receiver. If you mess that up, then it's going to be kind of a pain to try to get the pins out when they're already all connected and everything. It's kind of a big mess. So just one other tip there on the flight controller soldering. Hopefully that helps and gets you in good shape. And let me know if you have any other questions. Thanks.